In trying to solve the equation in example 3, I need to once again take a look at my denominator. Now, if I use my denominator and I tried to multiply my old numerators by the missing factors, then I would find that my equation would become what I call quartic. In other words, I'd have x to the 4. Now, I haven't shown you how to do this yet, and so this becomes problematic for me. But there's something nice that I'm going to be able to notice in this equation that's going to help me to find my solutions. If I, on the left-hand side, take out a highest common factor of 2, I have 2 into x squared minus 2x. On the right-hand side, I had 5 plus 3 over. And can you see that I have a expression that is reflected twice? Because here I again have an expression of x squared minus 2x. What I'm going to do in order to help me to solve this equation is I'm going to substitute a single variable in the place of that expression, x squared minus 2x. As x squared minus 2x appeared over here and over there, my substitution must go in both places. The substitution that I'm going to do is going to be k. So I'm going to say, let k be equal to x squared minus 2x. In other words, wherever I saw that in the original equation, I must replace that expression with k. On the left-hand side now, I'll have 2 times k, and on the right, 5 plus 3 all over k. Now you can see that if I find my LCD is going to be k, and by checking my previous denominators to see which numerators need this new factor, my left-hand side is going to definitely need it because it had been over 1. So it becomes 2k squared. The first term on the right also needs it, so it becomes 5k. But the last term on the right had a k already, and so it falls away. I can see now that I have a very nice quadratic equation that I can solve. Taking the terms from the right-hand side to the left-hand side, I get 2k squared minus 5k and minus 3 equal to 0. And using my trinomial method, I get two very nice brackets. The first one of 2k plus 1, and the second bracket is going to be k minus 3. And that is still all equal to 0. In other words, that means that 2k plus 1 could have been equal to 0, or k minus 3 could have been equal to 0. But I wasn't asked to solve this for k, and so I'm not even going to bother to find the solutions for k. I was asked to solve this for x. So at this stage, what I'm going to do is I'm going to take this expression for k, and I'm going to put it in the place of k in the two linear equations that I have now got in my last line. Putting x squared minus 2x back into the first equation, I find that I've got 2 x squared minus 2x plus 1 equal to 0. Putting that expression into the second linear equation, I get x squared minus 2x minus 3 is equal to 0. You can see that by doing this, I've broken my original equation into two quadratic equations. As I know how to solve a quadratic equation, I can progress quite nicely. So my first quadratic equation that I need to solve is going to be 2x squared minus 4x plus 1, all equal to 0. Now this is a difficult one because you aren't able to use your trinomial method. In other words, you're going to have to resort to using the quadratic formula. You'll remember that the quadratic formula gives you your solutions straight away. Using the formula, which is going to be minus b plus or minus the root of b squared minus 4ac all over 2a, and substituting your coefficients in correctly, you are in fact going to get two solutions. Your first solution in surd form is going to be plus 4 plus or minus the root of 8 all over 4. So your first solution is 4 plus the root of 8 all over 4. Your second solution is 4 minus the root of 8 all over 4. If I write this as two decimal places, I would find that my first solution from this equation is going to be when x is going to be minus 0,29, and the second is going to be when x is going to be equal to minus 1,71. Moving on to my next quadratic, this one is easy because I can use my trinomial method to solve this one. So finding first of all the two factors, my first factor is going to be when I have x minus 3, then I times that by the factor x plus 1. Each of these factors could have been equal to 0. So in other words, the two solutions that come from this side are when x is going to be equal to 3 or when x is equal to minus 1. As we started with a quartic equation, it stands to reason that I can have 4 possible solutions, and that is what I have over here. All that remains is for me to take a look at my original denominator and see whether there are any restrictions that I need to consider. As my original denominator was when x squared minus 2x was an expression in the denominator, that means that it is going to be when x minus 2 could have been equal to 0. So now I need to take a look at these restrictions. The restrictions are going to be when x is equal to 0 or when x is equal to 2. Neither of these two restrictions appear in my 4 solutions, and so all 4 of the solutions that I've found are in fact valid.